Hey coders, welcome to day 2 of 100 days, 100 lead code problems. But now I have renamed it as 100 days, 100 stories. Why problems? Because we are solving every problem through an interesting story. And today we are going to solve lead code 26, which is remove duplicates from the sorted array. Given will be an integer array sorted in non-descending order. Task is to remove the duplicates. So let's suppose this is the input. And you know who is our problem solver? Tom. So here is the long train, and Tom needs to find the unique compartment. Means there are several duplicate compartments as well, but Tom needs to find the unique one. So Tom is really smart. Tom is thinking, I will keep every unique compartment and create a new train. But likewise, here is a twist condition. So we have to return the same array with k numbers, first k numbers, which are not duplicates, the first k unique number. So return. So Tom thinks for a while and says, let me take a notebook. Tom took a notebook. Tom will traverse through every compartment. Whenever he finds a unique compartment, he will write that number in the notebook. But he writes every unique number on each page, every unique number on each different page. Suppose he goes for the first compartment. Now the notebook is empty, so he will write 1 here. On the second page, 1 already written. On the second page, he will write 2. 2 already is there. 2 already is there. 3, he will check 1 page by 1. Means 1, no, 3 is not there. 2, no, 3 is not there. 3, yes, 3 is there. So if there are thousands of pages, and if he wants to look for number 999, then he needs to look every time, and now he is tired. So what data structure we can use here? It's the list, integer, list is equals to new array list, and the size of the list will contain all number of the unique elements. And here he again needs to write back the numbers from the notebook to the train as well. So first of all, what the Tom will do, will traverse the train. So we will take a for loop for int I is equals to 0, I less than train dot length I plus plus. What he is doing, if train of I, what he is doing, he is checking if list is containing that one. So list dot contains train of I, not contains. If it's there, then do not add, but if it is not, then add it. Then list dot add train of I. The list will store all the unique elements. Now we need to write these numbers back to the array. We need to modify it. So for int I is equals to 0, I less than 10 dot length I plus plus, train of I is equals to list dot get I, and here we will return list dot size. Here not the train dot length, but here list dot size. What is the time complexity and space complexity of this program? We are visiting every compartment till the end the length of the train. So what is the time complexity for this one? Big of n, and contains also text big of n time complexity. So total time complexity big of n square. Because Tom is traveling each and every compartment and also checking that element is present in his notebook or not. So big of n time complexity to traverse the whole train, big of n time complexity to check every element. And what is the space complexity? Big of n, because we are using an extra notebook, which is a list. Now there are thousands of elements to thousands of elements. Now Tom is really tired to check every element one by one. Now he thinks, if by chance, if there is any superpower where I can find element in constant time, means if I dot 4, yes, 4 is present, 5, no, 5 is not present, like that one. What we can use means such data structure. Is there any data structure which store the unique elements and searching is in constant time? Yep. Set is there. But now we can use hash set? No, because order is not maintained in hash set. But there is something linked hash set where order is maintained. So we can use linked hash set. Now Tom found the superpower. So now what are the steps to implement that? So first of all, we need to create the linked hash set. So set integer set is equals to new linked hash set. Now traverse the train, and if the element is not present in the set, add it in the set, and again from the set to the array. So what we need to do for I and I is equals to 0, I less than train dot length, I plus plus. If element is not in the set, if set dot contains train of I, then please add, then set dot train of I. Now we have found all the unique elements and we have put that one in our set. Now from this set we need to put back into our array. So now for I and n in set train of I is equals to n, here we need to take one pointer, I is equals to 0 and then I plus plus, and here we need to return the length of the array where the first k unique elements appear. So we know the number of first k unique element is the size of the set, so set dot size, we can also write this. Now what is the space and time complexity? Time complexity is big of n, as we are traversing the whole train, and here it will take the constant time. Earlier it was taking the time of big of n, but now it is taking constant time, so time complexity will be big of n, and what will be the space complexity big of n, right? Then someone says, can you do this without using extra space? होते हैं ना कुछ कुछ लोग जो बोलते हैं यार ये कर दिया, ये तो बहुत सिंपल था, अभी ये करके दिखाओ. Then Tom scratches his head. Now time to call Jerry for the help. So Tom calls Jerry. The train. Tom and Jerry. Jerry looks at the train and says, Tom, listen, we don't need extra boxes or notebooks. We will use teamwork. Jerry says to Tom, Tom, you stay at one position and I will run ahead and find the next unique compartment. So Tom is here. Now Jerry is one ahead position of the Tom. Tom and Jerry compares their position. These two elements are same, so no need to take this one. Jerry go ahead. These two are not same, so हमें यहाँ पे इसको पटक देना है, and Tom will move ahead. So when Jerry finds a unique compartment, we will replace it one position ahead of the Tom. So 1 here will come 2, 2, 2. Rest of the part is as it is. Now Jerry will come here, and Tom is here. These two are same. Jerry will come here, here, and from here it will check. So 1, 2, 3. Now Jerry is here and Tom is here. Tom and Jerry. These two compare, these two are different. So 1, 2, here will come 4 after replacing. Tom will come here and Jerry will come here. So what we are doing, every time Jerry finds a unique element, we are replacing that one place after Tom. So we will take one left, which is 0, which will be Tom, and Jerry is moving ahead and traversing the train. So and right equal to 1, right less than train dot length, and right plus plus. What we are checking, if train of left is not equal to train of right, then change their position. Means then left of, then we need to put train of right after train of left, train of right and left plus plus. What we are doing, इसको यहाँ पे पटक दिया तो फिर टॉम को हम आगे बढ़ा रहे हैं, तो फिर ट्रेन ऑफ राइट को हमने बना दिया, ट्रेन ऑफ राइट को हमने बना दिया लेफ्ट प्लस 1 बना दिया, फिर टॉम को हमने इस पोजीशन पे लाया, एंड व्हाट वी विल रिटर्न लेफ्ट प्लस 1. And if the length of the train is 0, means there are no compartment. If the length of the array is 0, then we need to return 0. If train dot length is equal to 0, return 0. And this is called as 2 pointers. We took help of 2 variables to solve this problem, 2 pointers. And what is the time complexity? We are traversing the whole train, so big of 1. And what is the space complexity? What is the space complexity? Big of 1. Thank you. Follow for more DSA stories.